So let's get into subnetting. Let's start first with reviewing the facts about subnetting. The whole purpose of coming up with networks and these IP addresses is to ultimately get all of our devices within our network to be able to communicate. So it's very important that we get this down good. So let's start from the very beginning, talking about an IP version 4 address. These addresses are 32 bits in length and they're a binary string. When I say that, what I mean is the devices read the IP addresses in this form. We take this 32-bit string and we convert it into a dotted decimal format that it's easier for us humans to communicate with. So if you'll keep that in mind, when the router sees 64.192.16.1, it changes it to its view, which is the string of 32-bit binary numbers. When we get say a router's point of view of an IP address, we don't like that. We want to change it so that we can easily say, hey, IP address 64.192.16.1 instead of 0, 1, 0, 0, 0, 0, 1. You get the idea. Now, to convert from binary to decimal dotted form, take a look at the chart that I've created. The way you do this is you take the 32 bits and you divide them equally, 8, 8, 8, and 8. So you have 4 octets. If you will also notice, each octet value of the bits in that octet is the same. For example, if you're looking at the very first octet of an IP address, the first bit value is 128. So if you had a binary 1, 0, 0, 0, 0, 0, 0, 0, 3, 4, 5, 6, 7, 8. If this is your first octet that you're looking at, this is how the router would see it. This is how you would see it. Because you've turned on the 128-bit value, we're able to convert it to 128 so that we can see it and communicate it easier. Also, if you look up here again and notice that each octet is made the same way. So therefore, when you're working with each octet individually, you can stay with the value scheme to help you come up with what you're looking for. So if you do not have this memorized, if you're going to do networking, I'm sure you either already have or you're working on it. I always suggest going ahead and writing out your chart. So let's do that. 128, 64, 32, 16, 8, 4, 2, and 1. Again, this is the value of each bit in the position that it is in each octet. So no matter which octet you're in, the first bit of that octet has a value of 128. The second, 64, and so on. We can use this to help us. Now, another point I would like to get across before we go much farther is each octet has a total of 256 number combinations that can be placed in that octet. And what I mean by that is if you were to go through and you turn every bit on in the octet, you would add up each value to get a total of 255. Okay? So now, if you go through and you put a 0 in every single bit and add up all the values, the value is 0. So what I'm saying is you can put in any combination of zeros and ones, and by doing so you can come up with the numbers 1 through 255. If you put zeros throughout it, then you also come up with the value of 0. That means you have to add that 0 back in to your total number of 255 to get 256 possible combinations in that octet. If you can see that, that'll make everything forward even easier. That if you can see that there's 256 available numbers that you can put in each octet.